Alright guys, now we are going to dive into Chapter 3. Chapter 3 covers a lot of information. So, again, read the whole chapter, read all of the pictures, look at the diagrams that are in this chapter. I'm going to touch base with just the big things that you need to know, because it gives Chapter 3 is a lot of information. So get your highlighters out and let's get ready. Okay. Introduction to sterilization and disinfection. This is on page 52. The air and all objects around us contain microorganisms. The medical assistant is responsible for helping to reduce and eliminate microorganisms to prevent and spread of disease. This can be accomplished by practicing good techniques of medical and surgical asepsis. On the second paragraph there, physical and chemical agents are used to destroy microorganisms in the office. The agent selected depends on the intended use of the article. Please highlight that sentence. Now I want us to kind of go down a couple sentences. Articles that penetrate sterile tissue or the vascular system, such as surgical instruments, must be sterilized. Articles that come in contact with the skin, such as stethoscopes, blood pressure cuffs, and percussion hammers, should be disinfected. Sanitization, disinfection, and sterilization involve hazardous chemicals. It is essential for the medical assistant to know the precautions that are required when working with hazardous chemicals. I cannot stress that enough. Now we're going to look at the definition of terms. I want you to make sure that you highlight sanitization. Sanitization is a process that removes organic material. Please highlight that part. You have decontamination, detergent, disinfect. Please highlight this. A disinfect is an agent used to destroy pathogenic microorganisms. However, it does not kill the resistant bacterial spores. Disinfectants are usually applied to inanimate objects. Spore. Highlight this part. A spore is a hard, thick wall capsule that some bacteria form by losing moisture and condensing their contents to contain only the essential parts of the protoplasm of the cell. Spores represent a retesting and protective stage of the bacterial cell and are more resistant to drying, sunlight, heat, and disinfectants. So make sure you highlight that. Now let's go on down to sterilization. Sterilization is a process of destroying all forms of microbial life, including bacterial spores. An object that is sterile is free of all living microorganisms and spores. Please go ahead and highlight that. Let's go on to page 53. It's going to say that it's going to be the second little sentence there above hazard communication standard. The device most commonly used to sterilize articles in the medical office is the autoclave. We will be introducing the autoclave and how to work it and how to clean instruments when we are in clinic at some point. But the book will go into very depth of what you're going to use, what you want to look for, how to do it, things like that. All right, under the Hazard Communication Standard. The Hazard Communication Standard, HCS, first established in 1983, is a requirement of the Occupational Safety and Health Administration, OSHA. The purpose of HCS is to ensure that employees are informed of the hazards associated with chemicals in their workplace and the precautions to take to protect themselves when working with hazardous chemicals. That sentence needs to be highlighted. A hazardous chemical is any chemical that is classified as a health or physical hazard. A simple asphyxiant, a combustible dust, a pyrophoric gas, or hazard not otherwise classified. Health hazards include the potential of the chemical to cause acute toxicity, skin corrosion or irritation, serious eye damage or irritation, respiratory or skin sensitization, germ cell mutagenicity. That one's a hard one. Cancer or reproductive toxicity, or is an aspiration hazard. Physical hazards include the potential of the chemical to catch fire, explode, or react with other chemicals or materials. I want you guys to highlight in the very next paragraph the second sentence where it says, the GHS is an international standard that provides consistency in the classification and labeling of chemicals through the use of pictograms, signal words, and hazard warnings. The GHS classifies chemicals according to their health and physical hazards. Please go ahead and highlight that. In the very next paragraph, I want you to highlight where it says the GHS revisions to the HCS enable employees to quickly obtain and more easily understand information regarding the safe handling and use of hazardous chemicals. All right, now let's go on to page 54. We're going to start with the container label requirements. HCS requires that manufacturers label the containers of hazardous chemicals they produce according to GHS guidelines. The information on the container label allows the user of the chemical to tell at a glance the hazards of using the chemical and how to prevent or lessen exposure to the chemical. What you want to make sure that you highlight is going to be the product identifier, the supplier identification, GHS precautionary statements, and also make sure that you highlight in that where it says describes recommended measures to be taken to minimize or prevent adverse effects resulting from exposure to the hazardous chemical or from improper storage or handling. Highlight the GHS hazard pictograms as well as that first sentence. Highlight GHS signal word, GHS hazard statement, and supplemental information. Now we're going to start with the safety data sheets, or as otherwise known as STS, previously known as material safety data sheets. It provides more detailed information than the container label regarding the chemical. Most all offices, not only do you have your OSHA book, but you also have your SDS, and your SDS will maintain a copy and information over every single product you have in your office. So making sure that it stays up to date is very important. If you look on page 56, 57, and part of 58, that's pretty much what an SDS looks like. So, I mean, it breaks it down to you have your identification, your hazards identification, your section 3, the composition and information of ingredients, first aid measures, firefighting measures. I mean, it gives you everything that you need to know about that product. So going on to page 58, I want you to highlight where it says that a current SDS be kept on file for each hazardous chemical used or stored in the workplace. SDS must be readily accessible to employees and provide to them on request. That needs to be highlighted. And then right where it says companies that manufacture and distribute hazardous chemicals must provide an SDS with every product. So every time that you order a chemical, it should come with an SDS sheet. That sheet you're going to file in your SDS book. Most of the time, the SDS for me was always in my lab, which was also where my autoclave was and my eye washing station was. Because if I'm in any chemicals, the lab is going to help me figure out. I mean, that was just for me. That was where I always kept everything, so it was helpful. There are several safety data sheet requirements. Again, we kind of just went over those a little bit. But again, you have number 1, you've got your identification, your hazard identification, number 2, composition information on ingredients, first aid measures, firefighting measures, accidental release measures, handling and storage, exposure controls, personal protection. Number 9, physical and chemical properties. Number 10, stability and reactivity. And number 11, toxicological information. Number 12, ecological information. 13, disposal considerations. 14, transport information. 15, regulatory information. And number 16, other information. Let's go on over to page 60 under sanitation. Sanitization. Sanitization involves a series of steps designed to remove organic material from an article and to reduce to a safe level the number of microorganisms. Sanitizing instruments. Items most frequently sanitized in the medical office are medical and surgical instruments. This section focuses on the theory and procedure for sanitizing instruments. The general steps in the sanitization procedure of instruments are as follows: rinse, decontaminate, clean, thoroughly rinse, dry, check the instruments, and lubricate. There are 2 methods can be used to perform the cleaning step of the sanitization procedure: the manual method and the ultrasound method. Some offices have an ultrasound cleaner, some don't. So I don't know if we have an ultrasound, but you will be able to know the basics of doing it, because again, not all offices have an ultrasound method. We'll try to go over that as well in clinic. Let's go over to guidelines for sanitizing instruments. Number 1, wear gloves. That needs to be highlighted. Wear gloves during the sanitation process. While following the OSHA bloodborne pathogen standards, the medical assistant should wear disposable gloves during the entire sanitation procedure. This protects the medical assistant from bloodborne pathogens and other potentially infectious materials. It's going to go down a little further and say heavy-duty utility gloves should be worn over the disposable gloves to provide protection from the irritating effects of the chemical agents. That needs to be highlighted. Number 2, handle instruments carefully. That needs to be highlighted. That is a big, important one. Instruments are expensive and delicate, yet durable. They can last for many years if handled and maintained properly. Dropping an instrument on the floor or throwing an instrument into a basin may damage it. Instruments should never be piled in a heap because they become entangled and may be damaged when separated. Keep sharp instruments separate from other instruments to prevent damaging and dulling the cutting edge. Also, keep delicate instruments separate to protect them from damage. Number 3, follow instructions on labels of chemical agents. That needs to be highlighted. Later in that same number 3, it will say, also check the expiration date on the label of the chemical agent. Chemicals have a tendency to lose their potency over time and should not be used past the expiration date. That needs to be highlighted. Number 4, use a proper cleaning agent. A low sudsing detergent with neutral pH should be used to clean the instrument. Please go ahead and highlight that. Number 5, use proper cleaning devices. A stiff nylon brush should be used to clean the surface of the instrument. A stainless steel wire brush can be used to clean grooves, crevices, and serrations. A stain on an instrument often can be removed by causing a commercial instrument stain remover. So go ahead and make sure that's highlighted. Number 6, carefully inspect each instrument for defects in proper working condition. That needs to be highlighted. Number 7, lubricate hinged instruments. The lubricant makes the instrument function better and last longer. Go ahead and highlight that. You will see on page 62, 63, 64, and part of 65, all part of the sanitization of instruments. Please, please, please review that. That kind of gives you a visual on how to sanitize, clean the instruments. On page 65, where it says disinfection, disinfection is a process of destroying pathogenic microorganisms but does not kill bacterial spores. Please highlight that. On page 66, we are going to start with the levels of disinfection. Based on killing action, disinfection can be classified according to 3 levels. High level disinfection is a process that destroys all microorganisms with the exception of bacterial spores. I would highlight that. I would also become familiar with a semi-critical item. It's an item that comes in contact with non-intact skin or intact mucous membrane, such as a flexible fiber-optic sigmoid scope. That also needs to be highlighted. Intermediate level disinfection. Please highlight this. Intermediate level disinfection is a process that inactivates tubercle, I think it's bacilli. I don't think I pronounced that very good, but it is the agent of tuberculosis. All vegetative bacterial, most viruses, and most fungi, but it does not kill bacterial spores. That needs to be highlighted. Non-critical items are items that come in contact with intact skin, but not with mucous membranes, including stethoscopes, blood pressure cuffs, tuning forks, percussion hammers, and crutches. I would go ahead and highlight that. On the other side of page 66, where it says low-level disinfection, I do want you to highlight that where it says low-level disinfectants typically are used to disinfect surfaces such as examining tables, laboratory, countertops, and walls. That's really important for you to know. Okay, so under the type of disinfectants, I want you guys to look at paragraph 2, second sentence. It says, when working with glutaraldehyde, the medical assistant must work in an area that is well ventilated. Utility gloves and safety goggles must be worn to protect oneself from the irritating effects. Please go ahead and highlight that. And then if you notice on page 66, table 3.1, it does kind of give you a list of different disinfectants that you may use in your office. Okay, so now let's go on to 67. We have alcohol. You need to highlight where it says the disinfecting action of alcohol is increased by the presence of water. A 70% solution of alcohol is recommended. Stronger concentrations, 95 to 100, are not as effective, which I'm sure most people would actually think that they would be the other way around, but it's not. Just a 70% solution is recommended. Where it says the ethyl alcohol and isopropyl alcohol provide intermediate to low level disinfectant or disinfection, I would go and highlight just that little part right there. All right, let's move on down to chlorine and chlorine compounds. Chlorine and chlorine compounds are some of the oldest and most used disinfectants. Their most important use in the chlorination of the water. In the medical office, chlorine is used to form of hypochlorites, such as the liquid sodium hypochlorite or a household bleach. A 10% solution of household bleach in water inactivates tuberculosis bacteria, hepatitis B, C viruses, HIV, and many bacteria in 10 minutes at room temperature. Because of this, household bleach is recommended by OSHA for the decontamination of blood spills. That all needs to be highlighted. Going on to the other side on page 67, sorry guys, where it says phenolics. Phenolics are used mainly to disinfect walls, furniture, floors, and laboratory work surfaces. I would go ahead and highlight that. Let's go on down to where it says sanitize articles before disinfecting them. The article to be disinfected must be thoroughly sanitized. As previously described, sanitization includes the following steps: initial rinse, decontamination with the chemical disinfectant, cleaning, rinsing, drying, and checking for working order. It is important to remove all organic matter from the article before it is disinfected. If organic matter is still present on the article after it is sanitized, this prevents the chemical disinfectant from reaching the surface of the article to kill microorganisms. That sentence, two sentences, need to be highlighted. In addition, some disinfectants, organic material, can absorb the chemical disinfectant and inactivate it. The article should be thoroughly rinsed of the detergent after cleansing because detergent residue may interfere with the disinfecting process. The article must be completely dry before placing it in the disinfectant because water dilutes the chemical and decreases its effectiveness. That needs to be highlighted. Okay, so on page 68, I want you guys to come, again, you need to be reading all this, but I really want you, where it says properly store the disinfectant, I do want you to come familiar with the shelf life, the use life, and the reuse life. And I want you to highlight under the use life where it says, it's going to be the second sentence, use life is the period of time a disinfecting solution is effective after it has been activated. So please make sure you highlight that. And you're going to see on procedure 3.2, chemical disinfectants of articles. Cidex is a most common solution that most offices like to use. And it just kind of goes through the step on that, on what you can do. So I think that would be good for you guys to look over. Let's go on to page 7. Sterilization is a process of destroying all forms of microbial life, including bacterial spores. An item that is sterile is free of all living microorganisms and spores. Sterilization must be used to process all critical items. A critical item is an item that comes in contact with sterile tissue or the vascular system. That needs to be highlighted. All right, so then we have the autoclave. There are two parts of sterilization methods. There's your physical method and the chemical method. And then it's going to go into the autoclave. I do want you guys to be aware that the autoclave consists of an outer jacket surrounding an inner sterilization chamber. Under pressure, distilled water is converted to steam, which fills the inner sterilization chamber. The pressure plays no direct part in killing microorganisms. Rather, it functions to attain a higher temperature than could be reached by the steam from boiling water. That's important for you to know. We're going to go on down, let's see, 1, 2, it's going to be the third paragraph on page 71. Highlight where it says the autoclave is usually operated at approximately 15 pounds of pressure per square inch, PSI, at a temperature of 250 degrees Fahrenheit or 121 degrees Celsius. That needs to be highlighted. Let's see, I want you guys to go on over to the other side of page 71 under sterilization indicators. Materials that are being sterilized must be exposed to steam at a sufficient temperature and for a proper length of time. Sterilization indicators are available to determine the effectiveness of the procedure and to check against improper wrapping of articles, improper loading of the autoclave, and faulty operation of the autoclave. An article is not considered sterile unless the steam has penetrated to its center. Most sterilization indicators are placed in the center of the pack. The medical assistant should carefully read the instructions that come with the sterilization indicators. The most reliable indicators check for the attainment of the proper temperature and indicate the duration of the temperature. If an indicator does not change properly, a problem may be present in the sterilization technique or in the working condition of the autoclave. The manufacturer's guideline for proper sterilization techniques should be reviewed and the article should be re-sterilized. I would go ahead and highlight that. That very next paragraph, I would highlight where it says sterilization indicators should be stored in a cool, dry area. You will probably see these indicators. It's like a little stick, and basically when it's in the autoclave and inside your packs, it changes like to a brown. It'll change color, and that's the way that you're able to verify that the steam was able to penetrate all the way through the instruments and through the packs or whatever that you're autoclaving. So it's really good to use, and I always kept a record of those indicators as well in my my OSHA book. All right, on to page 72. You're going to see a diagram of an autoclave log. So every time that you clean your log, you load the log, what you set it on, everything's a log. So that's a good diagram or an example of an autoclave log. Let's go on down to where it says autoclave tape. An autoclave tape contains a chemical that changes color if it has been exposed to steam. So there again, something else is going to change color. And that way you can know. As a matter of fact, if you look on page 73, figure 3.10, that's exactly what it looks like. Autoclave tape. So I want you to highlight where it says autoclave tape contains a chemical that changes color if it has been exposed to steam. Onto the very next sign on page 72 where it says it merely indicates that an article has been in the autoclave and that a high temperature has been attained. Sterilization strips are commercially prepared paper or plastic strips that contain a thermolabile dye and that change color when exposed to steam under pressure for a certain length of time. Most sterilization strips are designed to change color after being exposed to a temperature of 200 degrees Fahrenheit or 121 degrees Celsius for 15 minutes. The indicator strip should be placed in the center of a wrapped pack. You guys need to highlight that very first sentence where it says that change color when exposed to steam under pressure for a certain length of time. And then again, highlight where it says the indicator strip should be placed in the center of a wrapped pack. Biologic indicators are the best means available for determining the effectiveness of a sterilization procedure. I would highlight that. Okay, now we're going to go on to page 74. And I want you guys to make sure you kind of, again, read these chapters. Okay, for page 74, wrapping articles. Articles to be sterilized in the autoclave must be thoroughly sanitized. Next, the articles are prepared for autoclaving by wrapping them. The purpose of wrapping articles is to protect them from recontamination during handling and storage. I would highlight that sentence. Articles that are wrapped and handled correctly remain sterile after autoclaving until the package seal is broken. The wrapping material should be made of a substance that is not affected by sterilization process and should allow steam to penetrate while preventing contaminants such as dust, insects, and microorganisms from entering during handling and storage. It should not tear or puncture easily. I would highlight all that. All right, so you have sterilization paper, sterilization pouches, and a mucilin. I want you guys to be familiar with each of these, but I do want you to highlight under the sterilization pouches On page 75, that very first sentence where it says sterilization pouches provide good visibility of the contents on the plastic side. Most manufacturers include a sterilization indicator on the outside of the pouch. So I do want you to go and highlight that. Now, the blue paper that you see on both 74 and 75, that is what I've always called wrapping paper. It's muslin. It's a reusable woven fabric that is available in different sizes. That's something you probably will see a lot. Most people use that. On procedure 3.3, and on pages 75, 76, 77, those are all really good diagrams, breaks it down. I would definitely make sure that you read that over. On page 78, where it says guidelines for autoclave operation, location of the autoclave. The autoclave must be placed on a level surface to ensure that the chamber fills correctly. The front of the autoclave should be near the front of the support surface so that the water can be easily drained from the drain tube into a container when the autoclave is being flushed. Filling the water reservoir. Distilled water is used to fill the water reservoir of the autoclave. Please highlight that. You cannot put anything else other than distilled water into an autoclave. On page 79, where it says loading the autoclave, there are 5 things to consider. 1, small packs are the best because steam penetrates them more easily. It takes longer for steam to reach the center of a large pack to ensure sterilization. A pack should be no larger than 12 by 12 by 12 by 20 inches. To allow for proper steam penetration, the pack should be packed as loosely as possible inside the autoclave, with approximately 1 to 3 inches between small packs and 2 to 4 inches between large packs. Packs should not be allowed to touch surrounding walls, and at least 1 inch should separate from the autoclave trays. I would highlight that. Number 3, jars and glassware should be placed on their sides in the autoclave with their lids removed. Packs that contain layers of fabric, such as dressing, should be placed in a vertical position because the steam flows from the top to bottom. This method allows the steam to penetrate the layers of the fabric. Number 5, sterilization pouches should be positioned on their sides to maximize steam circulation and to facilitate the drying process. Pouches can also be placed on the autoclave tray with the paper side up and the plastic side down. Timing the load. You will need to make sure that you highlight the length of time required for sterilization varies according to the item that is being sterilized. Most autoclaves will have, whether it's packs, pouches, it's a different time that's already set. But you do need to make sure that you are aware that there is various according, the length of time is different for each type of sterilization. Okay, let's go on over to page 80. You guys do need to make sure that you highlight where it says drying the load. The sterilized articles are moist and must be allowed to dry before they are removed from the autoclave. Microorganisms can move quickly through the moisture on a wet wrap and onto a sterile article inside, resulting in contamination. So when the autoclave is done, you generally will hear a big pop and steam will let out. You can open the door, but you want to make sure that you allow everything to cool down before you do so. And then I would still not remove the items from the autoclave until they are fully dried. We're going to go on over to where it says handling and storing packs. I do need you to highlight that second sentence where it says if a wrapped article is crushed, compressed, or dropped, the sterility of the contents cannot be assumed, and the pack must be re-sterilized. where it says this is known as an event-related sterility, meaning that the sterile pack is considered sterile indefinitely unless an event occurs that interferes with the sterility of an article. Sterilized packs should be stored in a clean, dry areas that are free from dust, insects, and other sources of contamination. Wrapped articles should be stored with the most recently sterilized articles placed in the back. I would go ahead and highlight that. Where under maintaining the autoclave, you do need to highlight number 2 under daily maintenance. But we are going to read those really quick though. Number 1, wipe the outside of the autoclave with a damp cloth and a mild detergent. Wipe the interior of the autoclave and the trays with a damp cloth. Clean the rubber gasket on the door of the autoclave with a damp cloth. Inspect the rubber door gasket for damage that could prevent a good seal. Now we're going to go on to page 81. I want you guys to go and highlight the second sentence under dry heat oven, where it says a dry heat is less corrosive than moist heat for instruments with sharp edges. And then we're going to go on down where it says on that second paragraph, the most commonly used temperature for dry heat sterilization is 320 degrees Fahrenheit or 160 degrees Celsius for 1 to 2 hours, depending on the article being sterilized. Over on the other side of page 81, where it says ethylene oxide gas sterilization, I do want you guys to go and highlight where it says it frequently is used in the medical manufacturing industry for producing prepackaged, pre-sterilized disposable items such as syringes, sutures, catheters, and surgical masks. That is something I do want you guys to highlight. Cold sterilization, you guys need to highlight the second sentence where it says only chemicals that are designed sterilants by the U.S. Environmental Protection Agency, or EPA, can be used for sterilization articles. Where we're going into the second paragraph under that, I need you guys to highlight that the item to be sterilized must be completely submerged in the chemical for a long time, 6 to 24 hours depending on the manufacturer's instructions. Prolonged immersion of instruments can damage them. In addition, each time an instrument is added to an instrument container, the clock must be restarted. So I would highlight that as well. Alright, so going on to this page 81, but mostly on page 82, 83, 84, and 85. You guys are going to be able to see her kind of walking through the process of the packs, how she's placing them in there, filling it up with the distilled water, the timer, and I will say that on 4D, that is pretty common on what the autoclaves in the offices do look like. So I would become very familiar with that. Okay, guys, that is all of chapter 3. It is a lot, I know, but I want you guys to remember that I'm only hitting the big parts of all these chapters. I do want you to still, again, you're going to get tired of me saying it, read every chapter all the way through. Read the case studies. Read the pictures, read the diagrams, read everything about it. If you come across things that you're in questioning or you're not sure, send an email. We have the Remind app. So there's ways of getting in contact. And for worst case scenario, write your question down. When we get back in the classroom, we'll go over everything. Okay? And we will be doing refresher courses over this, so don't feel overwhelmed. I want you guys to succeed. So we're just going to take it day by day. I hope you guys have a great day.